Hello everyone, welcome back to the tutorial series. Um, we covered couple of tutorials together and we have built a basic network. We inserted participant, we have manipulated, we simulated the trading, all those kind of things we did. I think it's now the time to dig deep into the this Hyperledger fabric. Before we go deep into the fabric, I think it's a good idea to sit back and see what are the various components in the Hyperledger fabric before we dig deep. So I have created a little document. I go to various it's an abstract document of the various concepts involved in the Hyperledger fabric. If you go to our main page, that is a blockchainbuddy.com, and there is a tutorials link, okay, in the main page. Okay, click that tutorials link. It will open various tutorials that we have already covered. So the deep down there is a link, Hyperledger components. If you click that link, the Hyperledger components link get opened. It has, so these are the some of the key concepts in Hyperledger Fabric. Member, membership services, multi-channel, private channel, peer, ledger, block code, chain code, consensus, transaction policy. Okay, we will cover them in detail, and these all are okay. Just keep in mind that these things exist in the Hyperledger fabric, but we will dig deep into each of them while we doing the other tutorials. Um, but yeah, let's start with the member. Okay, so an organization is a managed group of members. Okay, in the Hyperledger official tutorial, they have given a good example for that. This can be something as big as a multinational corporation or as small as a flower shop. So, a blockchain network can be formed with various members. So, this is an example of single set of member organization. Org one have one set of members. This is org 2. It have multiple entities inside that org 2. Okay, in the next slide. So right now we have a centralized system. Everything is centralized. The data is stored centralized. Um, so blockchain is decentralized, and consider these maybe banks. So each bank is connected to a network. They can interact directly. They can clear the transfer of funds or whatever process they do. They can easily clear those easily, efficiently, and with the less time they can clear all the transactions. That's the advantage of blockchain. A little introduction to Hyperledger. Hyperledger is a permission network, no anonymous access. All entities are known. Okay, back to the member. Member represent an independent entity. They are legally separate. Okay, consider an example. This is a blockchain network. We have four members in this network, four organizations. Okay, these are one organization. So car manufacturer, Ford is an organization, and Ford has a dealer called car dealer, and this car dealer then the car repair shop, and there is a regulator, DMV. So these all participants, all the organizations share the information. So when a car is manufactured, that information is shared with the DMV. When a car, then the car is sold to the dealer, that information is shared with these two car manufacturer and dealer, and the DMV is notified that. Then the dealers sell the car to a customer. That information is sent to the manufacturer. That information is sent to the DMV. Then in the car repair shop, when a customer comes to the car repair shop for example, emission testing, the repair shop does the emission testing, and that information flow to the DMV. So in this way, this network, all the participants are using this network to efficiently communicate with each other. Um, so that's a little bit about blockchain. And we have a blockchain. We have introduced the concept of member organization. Each one is an organization, and each one, yeah, member identities in Hyperledger are managed by certificates. Each member will have a certificate, that is his identity, and a cryptographic standard called FX509 is used. When a participant identity is created, certificate issued to the participant. When a transaction initiated by a participant, the private key is used to sign the transaction, and any component in the network can validate authenticity of transaction by using participant's public key. There is a participant will have a private key, and participant will have a public key. So public key is used for validate, private key is used for signing the transaction. We will see in detail that in later sessions. But just to feed into your mind that when a transaction is initiated, private key is used. When a transaction is validated, public key is used. Every component in Hyperledger got identity. For example, even for a infrastructure component like a server in Hyperledger network has an identity, a certificate. Every member has a certificate. Yeah, certificates are issued and revoked by an entity called certification authority, CA. Okay. Member can manage identity with their organization. A membership service provider. This entity, this service inside the every member organization will have an MSP. This they create revoke certificate. It can create certificate for participant, certificate for its infrastructure components. So every entity inside a organization, whether it's a member, whether it's infrastructure component, everybody has a certificate, and this service called MSP manages that. MSPs are part of a member. That means each member will have its own MSP. MSP provide two services. One is authentication, authorization. E-service valid or typo. It should be e-certificate valid. That's what this authentication means. Authorization means is user allowed to take this action? If there is a particular action, is he allowed? That also verified by this MSP. So let's see the diagram. This is the network. A user comes, and the first he has to get a certificate. So certificate request sent to MSP, and the request forward to certification authority generator certificate and flows back to the user, and the user at this point, when he get the certificate, he start communicating with the network. So this is where the MSP sits and certification authority. Okay, so this user seems to have a certificate already, so he is communicating with the network. Certificate authority, CA, issue, validate or revoke the certificate. Fabric CA have a server and a client manages certificates inside a database. Default SQLite can be configured to MySQL, PostgreSQL, LDAP. So if an organization has an LDAP, that can be linked to this certification authority. The person who manages certificate uses client to access the server. Okay, so this has a client access. um, okay, that's about. So far we cover. Let's go back. We have seen what is an organization. We have seen network. We have seen different participants in the blockchain network. We have seen members. We have seen certificate authority. We have seen MSP. Okay, now we are at the ledger part. Okay, ledger is one of the important elements inside the blockchain network. So ledger captures successful state changes. That means valid successful transactions as well as unsuccessful transactions. Ledgers are ledgers is kept at all peers and refers to as peer ledger. Okay, we will see what is this peer means. So they are ledgers are kept at peers. So ledger has two different parts. Ledger has a part called veiled state. Ledger has a part called blockchain. It is we blockchain is yeah and we can refer this blockchain as transaction log. So ledger has a part as transaction log that captures all the transactions, and it has a veiled state that captures current state of assets. Okay, we will dig little bit deep into these two sections. So let's consider veiled state. A database that holds current values of a set of ledger states. The veiled states make it easy for a program to get current value of these states rather than having to calculate them by traversing entire transaction log. So it make it easy to just get the current state. So that's the purpose of veiled state. It just captures, just provides the current state, but transaction log will have all the previous states. This provides easy access. Ledger states are by default expressed by key value pairs. We will see little bit in more details about this in the coming slide. The veiled state can change frequently as assets can be created, updated, and deleted. Okay, so now the blockchain part, that is called transaction log. It captures every transaction log that records all changes that determines the veiled state. Transactions are collected inside blocks that are appended to the blockchain, enabling you to understand history of changes that have resulted in the current veiled state. The blockchain data structure is very different from the veiled state because once written, it cannot be modified. It is an immutable sequence of blocks, each of which contain a set of ordered transactions. Okay, okay. Let's go to the next step. We have an example sequence. Okay, we have a transaction. Person A sells car to person B. So we have two parts, transaction log and veiled state. Let's see. Transaction log captures car sold person A to person B. Veiled state captures car, VIN number, owner as person B. Sequence 2. Now the person B's turn. He sells the car to person C. Transaction log captures car sold person B to person A. So there is two entries, person A to B, now person B to C. Failed state. It just shows the car belongs to person C now. So points to note. Transaction log is immutable. If we take card operations, green are possible, red is not possible. In a transaction log, we can create, we can read. Red, we cannot update, we cannot delete. In state data, we can create, read, update, delete. Okay, let's see what how this implemented in world state. Okay, by default level DV, but can be pluggable to other database. It's a key value store. When state data is updated, the existing data is not overwritten. That is the important part. So this when car is sold from B to C, the current state becomes C, but this is not, this is there in the world state, but it is not overwritten. The world state manages that old data by using a form of version. Okay, the visual representation of version, take the example of a car. Ownership of car is changed, so yes, the version representing car, the VIN number remains same, so VIN number version remains at 1, or version. So we will see. So this is how the version. Key car value OD version 0, key car 2 value, it has more information, type BMW, color red, owner gen version 0, like that. It stores as a version. I know it's difficult to understand. Let's try again. I have one more example. Okay, this is the version, this is the keys. We have a key called, this is version, this is key, this is value. Okay, VIN number, this is information about a car with VIN number 1 2 3 4 5 6. So VIN number version is 1 1 2 3 4 5 6. Owner, initial owner is version 1 BMW, who manufactures this car, and BMW sold to Ram, so the version is incremented to 2. And Ram sold this car to Sita, the version is incremented to 3. But the version of the VIN number remains same because this is not changing. Whoever owns the car, the owner only gets changed, the VIN number is not changing. So the VIN number version remains 1, the owner version remains, keep changing based on the owner the sale, or yeah. So yeah, I hope you guys could understand that. Little complicated, but if you go over one more time, I'm sure that you can follow that. So let's move to the next section. That's node and channels. So nodes connect to other nodes to form a blockchain network. So each of these can be considered as a node, and each organization is a node, and they connect and form the blockchain network. Unlike Bitcoin, in Hyperledger, not all nodes are equal. Each entity in the above diagram can be considered as a node. Each node will have a certificate. Every entity inside the Hyperledger has a certificate. A participant can connect to a node using his own certificate. Participant signs the transaction, but network use certificate of a node to check the validity of the transaction. Okay. Different types of nodes: client node, peer node, orderers. Okay, client nodes applications used to initiate a transaction. Peer nodes keep the ledger sync across the network. Orders transaction distribution. Orders make sure that all the transactions are distributed equally across the network and all the ledgers are in sync. They make sure that part. We will dig a little bit deeper into this various concepts of peer and nodes. So, blockchain network, peer represents peer nodes. So every net there will be peers and there will be smart contracts chain code. Each peer will have a chain code, each peer will have a ledger. Okay, let's try again. This chain code is a piece of code that assesses the ledger. Fabric implements smart contracts with chain code. A peer hosts ledgers and instances of chain code. There can be many ledgers and chain codes hosted on an individual peer. We will see that. Peers expose a set of API that enable administrators, applications to interact with the services they provide. Okay. Types of peers: anchor peer and endorsing peer. There are two types of peers: anchor peer and endorsing peer. They are very important parts of a blockchain network. We will see little bit deeper. So before that, I would like to show you a network. So this guy is the endorser peer, and this one is the anchor peer. And these all are general peers. They have the ledgers. So here comes the ordering peer, nothing but orderer. So he sits on top of all the organization, and it maintains communication channel. It acts as a communication channel between different networks, different organizations, and it keeps the organization sync current um, with the current data. Okay, so let's go back and see what all this anchor peer and endorsing peer. Peers in the organization receive transaction requests from the client. So peers receive the transaction request. Orderer creates blocks based on transaction and send back to the peer. Peer who receive the block is called anchor peer. Anchor peer validates block and update other peers. Anchor peer created part of channel configuration. Let's go back. Who is anchor peer? So this is the anchor peer. So this orderer creates a block and sent to the anchor peer. So one block is created. It send organization 1 anchor peer, organization 2 anchor peer. Organization A and organization B. Organization A has one anchor peer, organization 2 has anchor peer. That's the thing about this Hyperledger. Based on the requirement, we can have different combinations. See, here we have three pairs. Here we have two. Here are two anchor pair, one anchor pair. So different combinations are possible. So back to our topic. So order create a block and update it to the anchor pair, and anchor pair update to other pairs. So that's anchor pair. Anchor peers receive updated broadcast and update to other peers in the organization. Anchor peers are discoverable. So they this orderer communicates to anchor peer only. It for orderer it this is the one. It has got the visibility. That's what meant by discoverable or order peer. Anchor peers are discoverable. So any peer marked as anchor peer can be discovered by the orderer peer or any other peer. Okay. Client send invocation request to endorse a peer. So this is the endorse a peer. Let's see. This is number one. Client send an invocation request to endorser. Endorser. Let's see what endorser does. Endorser validates the transaction. So endorser does the validation, and if the validation successfully finished, it send back that information. And number three and four, the orderer get the information that everything is successfully finished. It create the block. Number five. Number five, it contacts the anchor peer and send the block to the anchor peer. So number five here, so company A anchor peer get that block, company five anchor peer get the block. The anchor peer update other peers six. See in the six, it updates every all other peers. That's how the Hyperledger Fabric workflow happens. So validate successfully finished. Endorser simulate the chain code and endorser validates the transaction. After validation successfully finished, endorser simulate the chain code. After it execute the chain code, it will not save the state to blockchain. It just simulate the chain code. Endorser will either reject a transaction or accept the transaction. Only endorser execute the chain code. Okay, that's other key point. Life cycle of a transaction. This Hyperledger fabric follows execute, order, validate that model. Transaction is executed in any order. When enough peers agree result of a transaction, it is added to the ledger and sent to all other peers for to make it current. This step is where the transaction given and ordering. So when it execute, there is no order. The ordering step where it get the order, and until the transactions are added to the ledger, there is no concept of one transaction happening before or other another transaction. Validate. Each peer validates and applies the ledger transaction in sequence. Now now that the transactions have a ordering, the peer can check whether a later transaction was invalidated or by an earlier transaction. For example, this prevents one item from being sold twice. So there is a validation to avoid double spending. All peers needs to update the ledger. So all peers do the validate step, but not every peer need to execute the smart contract. Okay, only one peer that execute the chain code or smart contract, that is endorsing peer. Hyperledger Fabric use endorsement policies to define which peer need to execute which transaction. That this means that a given chain code can be kept private from peers that are in part of endorsement policy. Transactions can be executed before they are put in order. This allows peers execute transactions in parallel. Fabric's three-step execute order validate model. The results of executing chain code for a transactions are explicitly agreed upon according to the endorsement policy before transactions are added. Let's see what is endorsement policy. Now there is a domain specific language used to define specifying the endorsement policies. There a policy can be like peers A, B, C, and F must all endorse a transaction of type T. So that may be the policy. So it to be a transaction successful, A, B, C, and F, all the peers in that network should agree, should endorse. There may be another policy like a majority of peers in the channel must endorse a transaction. That is enough to yeah, at least three. This many are there in the net, but only at least three needs to be endorsed. So various ways we can configure. We can use a special domain specific language for the specifying endorsement policies. Order execute model. The concepts of executing chain code and updating the ledger are combined into one idea: transaction. Fabric start with the transaction proposal. It bundles information used to trigger the specific chain code. The transaction proposal is sent to endorser peer. Endorser execute the chain code, which if it succeeds yields an actual transaction for the ledger. The endorsing peer then signs the transaction and returns to the proposal. Okay, that's about the endorsing peer. Let's look back to the channels. There is another concept called channel. Okay, let's see what all are there in this image. We have an organization 1, we have peers P1, P2, organization 2, um, we have P3, P4. There are 2 peers for organization 3, 1 peer for organization 4. So all these organizations are connected by a channel. Channel C is okay. So they communicate using this channel. But things will get a little complicated. Okay, coming back to our old blockchain network, we have a DMV, manufacturer, dealer, repair shop. They all are in one network. Let's look closer. There may be some informations that needs to be shared only with the dealer and a repair shop that need not be reported to DMV or need not reported to the manufacturer. So they decide to form their own private network, private channel. So that is possible. There may be another situation that the manufacturer and dealer need only communicator, so they will form their own network. So each channel will have a ledger and a chain code associated with it. So how many channels, as many channels needed based on the requirement we can form, and whatever the channel is there, there should be a separate ledger and a separate chain code. So that is multi-channel private channel. Then orderer, we have seen orderer, the importance of orderer. That is a communication service that guarantees delivery at, and orderers we have seen in detail. Orderers are not depend on one organization. Orderers are responsible for creating consistent ledger state across the network. Consensus built in fabric using orderer responsible for maintaining the order of the transaction. Blocks are created by order. Once created blocks are delivered to each peer in the network. Orderer guarantees atomic delivery of each block. It is implemented using Solo for dev and the production. We use Kafka. Provides communication layer within the network. That's the main role of orderer. When we create the network and deploy, we will create two roles, peer admin and network admin. So peer admin, network admin, peer admin create network admin creates the participants of the network. So business network card. There's another concept called business network card. Business network card provides all the information needed to the connect blockchain network. It is only possible to access blockchain business network through business network card. Business network card contains and identify for a single participant within deployed business network. The following okay, let's consider a script that use to generate a business network card. So a business network card should have the username, then what network it is used. So as a metadata, we load that information. Then there is a connection profile, the name, the type, the orderer, which orderer it is going to use, that URL we have to give, the certification authority information, what all peers it is going to connect, that information, and the channel, MSP ID, all those information need to be loaded. And okay, Basically a so business network card will have the credentials as well as connection profile, MSP, peers, orders, all those information it will have. Okay, business network cards are stored inside the home directory. So in Linux, this is the directory where all the business network card is stored. So we have discussed various components in the fabric. So we will see them in detail in the future sessions, but just just understand or just keep in mind that these components exist, and we will discuss more about them in future sessions. Thank you all for joining me in this session. See you in the next session. Bye.